Okay, creating your test plan. I'm going to start with an introduction to a concept that we're going to probably go into more depth on later in the semester. But let's talk about software quality assurance, okay? By the way, it's really dangerous to leave me in a room with a bunch of burners and matches. I've looked at this half a dozen times. I have been tempted. I know they had to look at for gas. I was eyeing this. Software quality assurance is the Achilles heel of most software projects. It gets the least funding, it gets the least respect, and it is the reason why so many projects are late, over budget, or fail altogether. Because managers, and quite often developers, but managers will just not believe that they have to spend the time and money necessary to ensure quality assurance. Now, I dare say none of those same managers would get on an airplane that they didn't feel had been checked to a fairly well, not only in its design and in its construction, but with regular maintenance. Yet software somehow, well, you know, we'll just have some people bang on it for a few weeks. And that's all the testing we need to do. Now, software quality assurance is not testing, not just testing. And it's not just quality assurance of code, it's quality assurance of all the deliverables. Requirements, specifications, architecture, design patterns, the test plans themselves. I did a white paper. I have mentioned in earlier lectures how object technology was seen as a silver bullet back in the 90s. I was doing consulting at Fannie Mae. Fannie Mae was adopting object technology, and there was a manager there who actually thought, oh, we're using object-oriented technology for programming. We don't need to use QA. And after I pulled my face out of my hands, I said, no, you actually need to do more QA with object technology because you're not familiar with object-oriented design and implementation. You're going to make more mistakes, not fewer. I ended up using a white paper and coming up with a diagram, which we'll see in a slide or so. But the point I made here is that it has to exist throughout the whole software quality department, and every person who touches any deliverable is responsible for the quality of those deliverables. You have to do a good job. Software doesn't magically heal itself. Specifications, requirements, designs don't magically fill in the gaps. They don't jump up and say, oh, by the way, this won't work when you actually have 10,000 users as opposed to 3. It is, and I promise you right now, this will be one of the big battles that you will face time and again in your actual job. In fact, I'll ask for a minute for those who actually face them. Core values in software. Jerry Weinberg says quality is valued in some person. And so when you're talking about quality values, it depends on what is important for your organization, for the customer, for the market. This is a decent list to work from. Reliability. Do you have errors or downtime? Performance. Is it fast enough? One of my architecture reviews at a finance company, they were replacing old mainframe assembly language software with distributed objects because they thought distributed objects were cool. And they're using a distributed object system to convert. How many of you know what ASCII is? Hey! Last class, nobody did. ASCII is an older coding standard, common to mainframes, especially IBM. ASCII is sort of the new kid on the block compared to ASCII, okay? So, this finance company had credit card processing software running on old Burroughs mainframes, and all the data was formatted not with ASCII codes, but with ASCII. And so they had to, in order to their new system to process, they had a 2-hour window each night in which to process all the credit card transactions. And so they were pulling the transactions in from the mainframes and converting them from ASCII to ASCII so their processing software could work on it. Yes?
Would you say that these are in order of importance?
Roughly. Very roughly. Particularly the first 3. After that, it really does depend on the job. Now, in this case, they had written this routine, this distributed object server to convert from ASCII to ASCII. Guess what? It was 1,000 times too slow. It could not, with the amount of data they had coming in, it was 1,000 times too slow. One of the consulting company I was within brought in one of our senior architects who sat down and replaced that whole distributed object ASCII to ASCII converter with 10 lines of C code in the lookup table and sped it up by a factor of 100. He said, you're still 10 times too slow, but now you're only 10 times too slow instead of 100 times too slow. I will note that this project later got canceled altogether. So you have performance, functionality. Does it have the features that you need? And of course, what happens when your project's late? You reduce functionality, throw them out. Compatibility. A lot of you are running into this. Your system has to interact with other systems and all their particular quirks and failings. Lifespan. It doesn't help to build a system that is obsolete 3 months after ship. It may not help to build a system that's obsolete 3 years after ship because it may have to run for years. You'd be surprised at how much old software is still running. Deployment, you have to actually be able to deploy it to its target environment in an acceptable time frame. Support, it's got to be written in a way so that you can fix bugs and add features, software maintenance. And cost. Basically, the cost of developing, deploying, upgrading, maintaining the system must somehow be justified. There are a lot of systems that have gone into production and actually were successfully deployed and used, but were so late or had so many functionality issues that they did not provide a return on investment. In other words, when a business company says, we're going to build a new system, or we're going to bring in a new system, or re-engineer a system, they're usually expecting that this is going to give us a competitive edge, we're going to reduce headcount, so we're going to get some benefit. We're not spending money for the sake of spending money. Awful lot of software doesn't meet that. Now, this is the diagram I came up with 20 plus years ago. And the concept here is that I have a whole more detailed lecture on this I'll give later in the semester, but I'm just introducing this here as a structure. The problem is that most software development, it looks like this. You're building and building and building and building, and at some point, you go through a magic box called test, and from that point, you go to a magic box called ship. Okay? The problem with this is that the later in the development process that you find defects in performance and reliability and functionality, the more expensive it is to fix. Remember Brooks, he says, roughly 50% of any schedule is spent on tests. The problem is most organizations don't plan for that, which is why you get projects that end up being months late, because they're doing the quality assurance late in the cycle. So what you've got, I actually have a laser pointer, don't I? Hey, look at that. So what you have here is your process activity. Now the process activity isn't just coding. Process activity is anything that produces a deliverable. That's analysis. That's requirements gathering. That's architecture. That's design. It is coding. It is implementation. It's building your test plans and your test suites. So what goes into that? The methodology you've chosen, any existing deliverables you have, which can be templates for various deliverables. If you're, refining stuff, again, I've emphasized over and over again with the stuff that you've been producing, go back and revisit it, improve it. So if you have an architecture document, part of your process is refining the architecture and producing a new and better, hopefully, architecture document. Guidelines and standards. Expertise. Some of you have started projects using technology that none of you have experience on. How's that worked out so far? Yeah. Okay, so part of quality assurance is making sure you have the right expertise on the team. And if you don't, you have to account for that in your scheduling. Key values of the company. Is the company interested in time to market? Are they interested in cost? Is it the footprint? We have to fit within X amount of megabytes or kilobytes or gigabytes of memory. We have to meet certain social standards or issues. All of these things feed into your process activity. You come out with your new or modified deliverable, then you test it, you have human reviews of it, you collect metrics on it. All three of those go into your evaluation of what you've just done. In other words, is this better? Is it worse? Is it getting closer? Then you've got feedback there to say, well, how can we do things better? You have, and we talked about bug databases, you have defect and feature management, saying here are defects we have based on our testing, here are bugs that we have to fix. And you have some form of configuration release management. So that is your code repository. This is so you check it in and you can roll stuff back and you can release. This is all wrapped around each and every activity here. So rather than have this idea of test as this box at the very end, this needs to be going on throughout the entire process. And this is just discussing what we talked about. Now, having outlined the ideal and recognizing you've got 3 weeks to your first demo. I actually toyed with having you do a test plan that had to address all those issues, but I didn't. So we'll just talk briefly about some types of testing that you can do. Unit and class testing. How many of you are doing unit and class testing on your code? Someone tell me what you're doing to accomplish that.
For this class or just in...
For this class, yeah. Yeah.
I'm sorry, what do you mean by how I'm achieving?
No. How are you using unit or class testing for your project here?
For mine, all of the code that I'm using for that third party, they require 75% code coverage on test cases. So I have 100 for what I've built so far. So.
Okay. Others? Who else is using test frameworks, unit testing, automated testing on your source code when you check it in? Anyone? Okay. And we'll talk about this when we talk on the next book about DevOps and continuous integration, continuous development. Need for highly automated testing to basically run the tests every time you check code in. In essence, this is building up in the system. So you've got the smallest modules, you've got some kind of testing. You have cluster testing, which are groups of related units or classes. Integration testing is trying to do something end-to-end and say, okay, I've got this, I've got my client, I'm doing something, it's going to the back end, it's fetching something, it's coming back, and it's talking to me. System testing is, now you can do integration testing in a test environment. System testing says, okay, let's see if we can actually make this work on a target environment. What problems we run into. Performance and stress testing. You would not believe, even to this day, how many organizations fail to do appropriate performance and stress testing. Stuff that works in the lab with 10 or even 100 simulated users can die horribly out in the real world when you suddenly have 10,000 or 100,000 users on a website. User acceptance and usability. Do the users actually like it? Do they understand it? Regression testing. This is also an area where I see a lot of projects really die. They basically have the code, they make changes, and all they test are the changes. They don't see whether or not they broke anything elsewhere in the code, either introducing new bugs or reawakening old ones because of that. Yes?
Do you think that's primarily because they haven't automated their testing? Because, I mean, if it's just like one button to run all your tests. Like,
Well, and that's it, because it's not automated. They don't invest in automated tests. This is why, again, if you look at CI/CD and so on, having highly automated tests, you do automatic regression testing as soon as you do the checking. A lot of organizations, they're not set up that way. Yes?
There's also a problem when you get into a lot of larger software projects where regression testing could take hours and possibly days. So it's usually something that might be performed right before a release, unless it's a continuous release cycle, in which case they wouldn't do that just because you don't want to wait a week for your tests to come back and say, oh, you failed one unit test here.
Yeah.
You know.
And part of that has to do with how you structure the application and how you structure the testing, because you want to find that out as soon as possible. Okay, building your test plan. I'll have these slides. I promise I'll get the slides up quickly. I'll get them up today. Feel free to go back to the earlier wikis and just cheat and grab other people's test plans and use those as templates. That's actually the single best reuse is usually reuse of deliverables, not reuse of code. It's like, okay, here's a great format for a test plan. I'll just delete all the text and put mine in there. Your test plan should tie back to your requirements and design. In other words, you're testing to see that you're meeting your requirements of design. You're checking for reliability, performance, and functionality. Your test plan should indicate what tests are being done and when they are done. Should indicate what constitutes success, some form of user acceptance. Now this is something where I think all of you as teams are going to have to do some work on this. Most of you have someone designated as QA, but I strongly suggest that you're going to have either some distributed conferences or team meetings, and possibly parceling out portions of the test plan to get this done. And that's it, so let's take a break and let's start again at 5 minutes till the hour. So if you hurry and get to the bathroom, for instance, at 5.